Okay, we're gonna do balancing equations today. And so first of all, with writing chemical equations, the way we're gonna write them, the reactants are gonna be on the left, and then we're gonna have an arrow going to products. Okay, so we're going to have reactants on the left, products on the right, and this arrow means makes or is going to. Sometimes you might see a double-sided arrow. That just means that the reaction is reversible, that when the products form, then so they can break back down to form reactants. But we're not really going to worry about that right now. So we're going to say reactants on the left, products on the right. And the way they're written, if there's a big number in front, that's the coefficient. And that's telling you how many of that substance there are. Now, A and B, B is not boron here. This is just example that don't exist. So 2A means that there would be two separate atoms of A. And B2 with the subscript, now that means that they're bonded. So that means B is bonded to B. And then over here for our product, we have 2AB that the 2 in front tells you that you have two of those things that are bonded together. So two separate ABs that are bonded. Okay. And you cannot change the subscripts when you're balancing an equation. The subscripts are how they're bonded. So with ions, we balance the charges in a specific way to make them add up to zero. Those subscripts are set. Or with molecules, this is the way they're bonded together. Those are set. So you never can change the subscripts, only the coefficients when you're balancing. So an example of the real equation is 2H2, and so that means two separate molecules of two H's bonded to each other reacts with one molecule of O2, and if we were drawing the dot structure, it would be a double bond between the two oxygens, makes or goes to two molecules of water. Okay, so 2H2O. So this, again, coefficient is saying how many of the substances there are, and coefficients have to go in the front. Subscripts say how many of that atom there are in the formula. So in this one with water, that little 2 subscript only applies to hydrogen, but the 2 coefficient in front applies to the whole substance, that there's 2 water molecules. So if we were counting up individual atoms, it would be 2 times 2. There would be 4 hydrogen atoms and then just 2 oxygen atoms. Okay, so coefficients versus subscripts. As far as states of matter, we have solid if it's in parentheses S. We have gas if it's in parentheses G, and L in parentheses, that's an L, is liquid. And then AQ in parentheses after a substance means it's dissolved in water. That's called aqueous. Right now, we're really not going to worry about those states of matter, but later on, we will be putting those in. They don't affect how you're balancing the equation or anything. They're just giving more information about what state the substances are in. So again, coefficients, they're the big number. They're in front of the molecule or the atom, and they can only be written in front. You can't write them in the middle if you need to change the number of atoms of something. Okay, so coefficients can only go in the front, and then subscripts are the small ones within a formula telling how many atoms there are in that formula. Okay, and those cannot be changed. Once the formula is made, you can't change that just because you need more hydrogen or oxygen or whatever. Okay, so subscripts can't be changed. Coefficients have to go in the front. You can't put a coefficient in the middle of a compound just because you need more of something. So we want to balance these equations. So looking at this first equation, we see we have 1K and 2 Fs on the reactant side, and we only have 1K and 1 F on the product side. So I'm going to put a 2 here to get 2 fluorines, but that also means I now have 2 potassiums, so I come back over here and put a 2. Okay, and that one is balanced. That was pretty simple. When they're a little more complicated, it's a really good idea to put a little list of each. Take inventory before you start balancing. So with this one on this side, I have calcium, I just have one. Over here, I have 2 hydrogens, and I only have 1 oxygen. Again, that 2 only applies to the hydrogen. Over here, before I do anything else, I have 1 calcium. This 2 now applies to both of the things in the parentheses. So I have 2 oxygens and 2 hydrogens inside of there. But then over here, I have 2 more hydrogens. So I actually have 4 hydrogens to start with before I put in any numbers. Okay, so then I see, oh, okay, well, if I put a 2 in front of this, that will make my hydrogens 4, 2 times 2, and then my oxygens will be just 2, and then they're balanced. 1 calcium on each side, 4 hydrogens on each side, 2 oxygens on each side. Okay, moving on. With this one, I noticed that I have a polyatomic ion, and it's the same on both sides, and there's no other sulfur or no other oxygen. So it's actually easier just to leave the polyatomic ion together as long as it didn't split up at all and there's no other sulfur or oxygen. So over here, I'll say I have 1 copper. I'm going to keep that sulfate together just to make it a little easier. I have 1 sulfate and I have 1 iron. On this side, keeping them in the same order, I have 1 copper, I have 3 sulfates, and I have 2 irons. So I can come over here and put a 3 here to make my sulfates 3, which also makes my coppers 3. I can come over here and put a 2 here, which makes my irons 2. And lastly, I can put a 3 here to make my copper 3. And then it's all balanced. If I would have taken the sulfur and the oxygen separately, okay, I can do that. So I could have said, okay, well, to begin with, I had 1 sulfur and 4 oxygens in that sulfate. And over here, to begin with, if I'm ignoring the sulfate, I had 3 sulfurs and 4 times 3, I had 12 oxygens to begin with. Then when I was balancing, I have a 3 here. Okay, so that would make my sulfurs 3, and that would make my oxygens 12. And I come up with the same result to balance it. It's just a little easier. If the polyatomic ion didn't split up, you can leave it together on both sides. But either way is fine. You can take the individual elements also, okay? A couple other little things. We have something where there's 7 elements that cannot exist alone. And they're called diatomic. That means that they're 2. So hydrogen cannot exist as just H in a reaction. It will be H2 if it's just hydrogen gas. And the same thing for oxygen. If it is in a reaction and it says oxygen gas, it has to be O2, not O. So I call these Hofbrinkel. Some people call them Brinkel-Hoff. There's 7 elements. And on the periodic table, if you look at your periodic table, from nitrogen, oxygen, fluorine are in a row. And then underneath fluorine is chlorine, bromine, iodine. So they make a number 7, plus hydrogen is over on the periodic table off by itself. So those elements cannot be alone in a equation. So if it says, again, like chlorine gas, fluorine gas, it has to be diatomic, F2, Br2. There is no such thing as H by itself or Br by itself. Now that doesn't mean in another formula there can't be a single H. Yeah, HCl is hydrochloric acid. HBr is hydrobromic acid. KCl has just 1 Cl in it. Okay, so as long as they're with something else, that's fine. But you cannot just have H plus something or O plus something, okay? They're diatomic. So for example, in the equation below, where it says when potassium chlorate is heated, oxygen gas and potassium chloride are produced. So you have to be able to write the equation from the words and then balance it. So this is why you still have to have your polyatomic ions known. You still need to know the charges of things and how to make ionic compounds and all that. So the naming and the formula writing will just be continued to be used the rest of the year. So potassium chlorate. Well, potassium is +1. Chlorate, the polyatomic ion, is ClO3 -1. So potassium chlorate is just KClO3. It says it's heated. So that means, if you want to, you can put a little triangle. That means heated. And it means that's the only reactant. It's heated. It's not mixing with anything else. So then what comes next after the comma is going to be the products. So oxygen gas, which has to be O2, not just O, and potassium chloride. So again, potassium being +1, it's a plus, and Cl as -1, so potassium chloride will just be KCl. That's our base equation. That's just from the words. When potassium chloride is heated, oxygen gas and potassium chloride are produced. So now to balance it, I notice right off the bat that I have 2 oxygens on one side and 3 on the other. Anytime you have an odd number on one and an even number on the other, you're going to have to multiply the one that's odd by 2, at least by an even number, and then that would mean that would be 3. So right now that would give me 6 oxygens on both sides. Okay, and right now I have 2 Ks and 2 Cls on this side. So over here, if I just put a 2 there, 2 Ks, 2 Cls, and it's balanced. Okay. Also, if you have in words phosphorus, usually you should write P4. Now this one, people aren't as picky about. The Hofbrinker ones for sure. You can't have O or H, doesn't exist. But sometimes people will just write P instead of P4. It's okay, but to be absolutely correct, it should be P4. And same thing with sulfur. Sometimes people will just write S, but to be absolutely correct, it should be S8 and P4 when it says phosphorus is reacted with or sulfur is reacted with. Okay, so P4 and S8 are what they should be. But metals will never be diatomic or triatomic or whatever. If it says copper is reacted with this, it's just Cu. If it says iron is produced, it's just Fe. Okay, do not put Cu2 all by itself or Na2 by itself. They are not diatomic. Okay, they are just metals. All right, and then lastly, these are 3 acids that you do need to know. You should write these down in your notes. You do need to know the formula for sulfuric acid. That's H2SO4, sulfuric acid. Hydrochloric acid, the most common acid we use, HCl. And then sometimes we'll use nitric acid, HNO3. Okay, so we're not going to talk about naming acids right now. We will later. So right now, just know those 3 acids: sulfuric acid, H2SO4, hydrochloric acid, HCl, and nitric acid, HNO3. And then you have a paper of reactions to balance, and then some to write out first, and then balance.